We'll focus on reviewing chemical and physical changes. That's actually what's covered in Chapter 8. And then today we're going to work on learning how to balance equations. And so these are skills that we'll need in Chapter 9. So we're going to go ahead and go through, like I said, two things: physical, chemical changes, and balancing. So the first bit is on chemical changes, and we know chemical changes occur when a substance is converted into one or more new substances. So our example here is silver that's tarnishing. And so silver can actually react with kind of sulfur in the air, right? And then it can produce silver sulfide. And so this will make your silver look really dull, right? So this would be a change in color. That's how we would recognize that it's gone from silver to silver sulfide. So like when I was a kid, my grandma used to make me, polish the silver, and you use this silver polish, which actually reacts with the silver or with the sulfur and pulls it off and returns your silver back to the way it was, which is cool. It's kind of like rusting essentially. But yeah, so this one we are seeing a change in color. So here is some more examples of evidence of a chemical reaction. So if you'll recall, though, we have those 7 characteristics of a chemical change, and those are actually all on your lecture worksheet. So if you look at your Chapter 8 lecture worksheet, hopefully you have it in front of you. There are 7 characteristics of a chemical change. So you have gas production, light production, unexpected color change, odor change. Things are endothermic, right? They'll absorb heat. Or if they are exothermic, they will produce heat. And then we will also have formation of a precipitate. That's this one down here. That's the one that's the most challenging for people. Formation of a precipitate is when you pour together 2 liquids, 2 seemingly kind of clear liquids, and they form this solid out of nowhere. So that's what's happening here. But yeah, otherwise, know your 7 characteristics of a chemical change. We've been talking about those all semester, so hopefully those are familiar to you now. So go ahead and pause here and work on problems 1 and 2 from your lecture worksheet. Again, those are just reviewing chemical and physical changes. Those should be reviewed. That's stuff we learned earlier in the semester. Like I said, the only reason we're talking about it again is because it is covered in Chapter 8. So go ahead and pause. All right, so also covered in Chapter 8, and we're going to work on this more during the next set of slides, is how to actually write out a chemical reaction. So we're going to talk about it briefly today. We're going to get more in depth next time, but just so we see, so on the left here, like if we were going to write this reaction, carbon and oxygen gas to produce carbon dioxide. This stuff on the left, on this side, these are the reactants. Okay, so the stuff that is doing the reacting, we call those the reactants, and the reactants. The stuff on the right side, the stuff that is made during the reaction, we call that the product. So instead of continually saying the left side and the right side, we can say reactants and products. And the arrow in the middle, right here, separates the reactants from the products, and is always telling us the direction of the reaction. In this class, that arrow will always be going to the right. In higher levels of chem, it can go other directions, but in this class, it will always go to the right. So here is some really common symbols that we see. So if we have more than if we have more than one thing that's reacting, so if we have 2 or more, then we include this plus sign between them. That's just telling you like, this reacts with this. So this plus this, right? This reacts with this. That's what the plus is meaning. And then the arrow will show you the direction of the reaction and is indicating what is being produced in the reaction. It's always going to point at the products. And then we have these phases of matter. So when we're looking at a reaction, did it have it on this last slide? Oh, it did. When we're looking at a reaction, so like it's always written after it in parentheses, like so carbon is a solid, oxygen's a gas, carbon dioxide's a gas. So these little letters here are telling you what state of matter your reactants or your products are in. So S stands for solid, L stands for liquid, right? That's a cursive L. So like if we were writing it, we would write it in cursive like this on paper. It's the only one that's cursive. I don't know why it is. It just is. And then G is for gas, and then AQ stands for aqueous. And aqueous, so it says it down here, aqueous means dissolved in water. So like salt water is an aqueous solution of sodium chloride. So it's a fancy way, right, of just saying, so like if you put, salt in water, that's now an aqueous solution of sodium chloride, which is table salt. So aqueous means dissolved in water. Most times, if we think something's a liquid, it's actually not. It's actually aqueous because it's usually dissolved in water. The only things we're actually going to put L for are going to be things like water. If you see water, it's typically going to have a cursive L. And maybe, sometimes you may see like bromine or something like that, or it may tell you that it's a liquid. But if it doesn't tell you it's a liquid, it's probably a solution, which means that it will likely be aqueous. So just pay attention to that. Something to keep in mind. We're going to work more with these phases of matter next time. And this last one, this little triangle that you're seeing here, this little delta, that is telling you that during the reaction, right? During the reaction, it's being heated. So that means we stuck it on a hot plate or we put it over a Bunsen burner or something like that. But that's what the triangle means, is that it's being heated. So what is a chemical equation? So a chemical equation describes a chemical change of some kind. So we have some parts of an equation here. So if we're looking at this, right, the stuff on the left-hand side, those are our reactants. Again, that's what's doing the reacting. And since we have more than one, like we were talking about before, we're going to put our plus sign in between them. And then we've got our products over here on the left. Again, on the right. Again, there's two of them being made, so we put a plus sign in between. And then this arrow in the middle is showing us that they are, reacting. This is the direction of the reaction. Okay, so the reactants are what you start with. Those are always going to be on the left-hand side. And the products are whatever you're ending with, whatever you're making. And those are going to be on the right-hand side. So we have other things. Subscripts show how many atoms of an element there are in a molecule. So like water. If we take water as our example, water has 2 atoms of hydrogen. Because there's a 2 here, right? This 2 tells you there's 2 hydrogens. And there's only 1 oxygen because there's nothing here, right? So that's an imaginary 1. So 2 hydrogens, 1 oxygen. So these are called subscripts, right? These are the numbers at the bottom. Okay, so these, I want you to remember this. These cannot change, okay? We're going to get to where we're going to change numbers around a little bit. Do not ever change the subscripts of a molecule, okay? I like to say that like subscripts save lives, right? This formula, this is water. If you drink some water, you live. If, this is hydrogen peroxide, right? This has a different subscript on the oxygen. Instead of it having a 1, now there's a 2. You drink this, you don't live, right? So subscript saves lives. You drink this one, you drink water, you live. Hydrogen peroxide, not so great. So subscripts save lives. Make sure you don't change the subscripts, okay? But the coefficients show how many molecules there are of a particular chemical. So this will be a number in the front here, this 3. This 3 is telling you, okay, you have 3 waters total, okay? So these are the ones, these can change, okay? And we're gonna look at how to manipulate these coefficients throughout the lecture today. Okay, so we have this thing called the law of conservation of matter. And the law of conservation of matter states that in a chemical reaction, matter can't be created or destroyed. This is one of like the laws of the universe. You can't create or destroy matter. This is like why we know Harry Potter is not real, sadly, right? You can't create or destroy matter. Things can't just poof into nowhere. So another way of saying this is that the number and types of atoms that are going into a reaction must be the same as the number and types of atoms that are coming out. So the number of each atom that you have on the reactant side has to be equal to the number of each reaction that you have on the product side. You can't create or destroy carbon atoms or oxygen atoms along the way. So we are going to do what's called balance these chemical equations so that they obey the law of conservation of matter. So here's, if that's not clear, we're gonna go through lots of examples. So here is a reaction right now. So on our reactant side, right, on this side, these guys are our reactants. Right now we have, this is called methane, this is carbon tetrahydride. We have oxygen gas. So right now we have one carbon atom because this is an imaginary one here. And then we have 4 hydrogens and then we have 2 oxygens. So this is what that's what this breaks down to. And on the product side, we have an imaginary one here, right? So we have 1 carbon and then we have 2 hydrogens coming from that water. And then total, right? We have 2 here and we have 1 here. So total we have 3 oxygens, okay? And I would always make sure to write how many you have total on each side. So if we look though at these numbers that we've written down, we have 1 carbon on each side, which is great, right? Carbons, they match. But the hydrogens, right, on the left side, on the reactant side, we have 4 hydrogens, and on the product side, we have 2 hydrogens, which would lead us to believe that during this reaction, 2 hydrogens have just like poofed into nowhere. So this is not balanced. This is not obeying the law of conservation of matter right now. And then similarly, looking at the oxygens, on the reactant side, we have 2 oxygens, and on the product side, we have 3. So we created an oxygen kind of along the way, which again, you can't do. So that disobeys the law of conservation of matter. So right now, the only one that's balanced are the carbons. So what we're going to do is we are actually going to add numbers in the front so that we will balance these along the way, okay? But we'll come back to this particular one later after we talk about how to balance things. So every reaction is written as a balanced equation. So you always, from here on out, need to make sure that your equations are balanced. And what that means is that you have the same number of atoms of each element in the products and the reactants. And the way that we do this is we add coefficients in front of these molecules, okay? Do not put numbers in the middle of molecules. Do not change subscripts. The only places that you can put numbers are in the front here, okay? You can only add coefficients. You can't put numbers anywhere else. So if we look at this one now, when it's balanced, right? This has already been balanced for you, but when it's balanced, we think about hydrogens on this side. Right now, we have a 2 in the front here. So it's multiplying by this 2 for a total of 4 hydrogens on this side. And our oxygens on this side, right? The 2 here is being stopped by this plus sign. So the 2 that's out here can't go to the oxygen. So our oxygens, we just have this O2, right? So that is telling us there's 2 oxygens. And then looking over at the product side, for our hydrogens, we have 2 times this 2 subscript that was already on the hydrogen. So we have 4, and this is an imaginary 1, right, on water. So we get 2 times 1 will give us 2 oxygens on this side. Okay, so that 2 in the front of water has to get distributed to every element that's in there. So then when we look, we have 4 hydrogens on each side and 2 oxygens on each side. So this is balanced. So that is what we are going for. Okay, we're trying to make sure that they are balanced. So we're going to add numbers in the front. We're going to add coefficients until we get the same number of reactants and products on each side. Okay, so if we look at this one, I meant to leave those out, but that's okay. If we look at this one, now numbers have been added in the front here. We've added a 2 in a couple places to make them balanced. So if we go through and we recount, right, there's an imaginary 1 here on this carbon, So there's 1 carbon and there are 4 hydrogens. And now by putting this 2 in the front of oxygen, we go 2 times 2. So now we are getting 4 oxygen atoms here. And then on the other side, we have 1 carbon. We have 2, well, here, we'll look at oxygens last. But the hydrogens, this 2 gets distributed here. So now we have 4 hydrogens. And then total oxygens, we're getting 2 oxygens from the carbon dioxide plus 2 times this imaginary 1 down here. So there are 2 oxygens over there for a total of 4. Okay. So now if we're looking on both sides, we have 1 carbon, right? 1 carbon, 4 hydrogens, 4 hydrogens, 4 oxygens, 4 oxygens, which means it is now balanced. Okay, so that's what we're going for. So we're going to add numbers in the front. We're going to add coefficients so that we balance these chemical equations. I'm going to go through quite a few examples in just a minute, but before that, go ahead and do problems 4 and 5 on your lecture worksheet. And problems 4 and 5 are just going through and having you count up how many of each atom is on each side of the reactant, and then of each side of the reaction, and then determining whether or not those problems are balanced. So I'm going to pause here so that you can work on problems 4 and 5. Like it says there, skip problem 3 for now. We're going to do it in the next set of slides. Just go ahead and go to problems 4 and 5, do those, and then come back. So we're going to learn some rules on how to balance these chemical equations. Okay, so the biggest rule of the game is you cannot create or destroy matter, right? So that means that you need to end up with the same number of each atom on each side of the reaction, okay, so that you're not losing any along the way. Subscripts, right? The numbers at the bottom cannot be added, removed, changed, right? Remember I told you subscript saves lives, so do not change those in any way, shape, or form. You can only change the coefficients, right? Those numbers in the front, you can only change the numbers in the front. Can't change numbers anywhere else. And then this one, coefficients can only go in the front of a chemical formula, never in the middle. So you can't put like a new number in the middle of H2O. You have to either put it in the front of water or not at all. So we got some tips. Okay, try balancing big formulas first, ones that have like multiple elements in them, and then save the elements that are floating around by themselves for last. This one is a little more advanced. If the same polyatomic appears on both sides of the equation, you can treat it as a unit altogether. You can like balance polyatomics, kind of like you balance elements. Like I said, that one is going to be a little more advanced when you get there. And then the main rule is there's no real particular way to balance these equations. Some are harder to balance than others. Some require a little bit of creativity. The best thing you really need to do is practice, okay? So there's, you just need to spend some time and practice doing this. You can kind of think of it as like a puzzle almost, if you like puzzles. If you hate puzzles, don't think of it as a puzzle, but I like it because I think of it as a puzzle. So here's my tips for balancing. First thing would be to identify all types of atoms. Like, okay, I have carbon, hydrogen, and oxygen. And then you're going to write those below the reaction. And then you're going to figure out how many of each atom you have to start with. And then you're going to figure out which atoms occur in only one compound. And you would start with balancing those. And I'm going to show you some examples. This will get easier as you go. But I would do this. I would never start with oxygen and hydrogen. I would always do those last. This is because they show up usually in multiple places in the reaction and can cause you trouble. So if you're stuck, you may have started with oxygen or hydrogen, and I would just erase everything you've written and start over. And then we're going to insert coefficients. We're going to put numbers in the front, and we're going to change our atom counts as we go so that we can see, if we're balanced. And then we're going to double check our values right at the end. So here we go. This is going to be easier in examples. So here we are. So this is an equation, and we need to see, is it balanced? And if not, then we're going to go and balance it. So the first thing I would always do is figure out how many of each element you have on each side of the reaction. So we have iron, and we have oxygen, and we have hydrogen. Okay, and then on this side, we have iron, we have oxygen, and we have hydrogen. I always write them in the same order on each side, just so I can see really easily if they're balanced or not. So over here, on the left, we have 2 irons, because that 2 has a subscript, right? So we'll put a 2 there. And then we have 3 oxygens, and we have 2 hydrogens. Over here, iron doesn't have a subscript, so that's going to be a 1. We have 2 hydrogens, or sorry, 2 hydrogens. Make sure I put that in the right spot. And then we have an imaginary 1 on our oxygen. So if we look, the only thing that's balanced right now are our hydrogens. Otherwise, our irons aren't balanced and our oxygens aren't balanced. So like I was telling you before, the easiest way is to leave the free elements by themselves. So if you look, iron right here on the product side is sitting by itself. So I wouldn't start with iron because that could cause us trouble. Instead, let's do oxygen. Let's balance this oxygen. So on the left-hand side, we have 3 oxygens, and on the right-hand side, we only have 1. So what we need to do is put a number out front, out here, that is going to multiply by this imaginary 1 to equal 3 over on this side. So we're going to put a 3 there, because 3 times this imaginary 1 will give us 3 oxygens. But when I do that, you'll notice, right, because this 3 distributes to the oxygen, but it distributes to the hydrogen as well. So instead of having 2 hydrogens like we did before, now we have 3 times 2, which gives us 6 hydrogens on this side. So you may be thinking, well, that didn't help. That messed everything up, right? Our hydrogens were balanced. True, but we can balance them again. So now let's go back. And let's look at the hydrogens, right? We messed them up. Now we have 6 and 2. So we need to put something out front here that is going to multiply by that 2 to give us 6 like we have on the other side. So if we put a 3 out front here, then we go 3 times 2 will give us 6 hydrogens over there. So now our hydrogens are balanced, our oxygens are balanced, and the last thing we need to do is balance our irons. So we have 2 on the left, only 1 on the right, so we put something out here that will multiply by this imaginary 1 to get us 2. So 2 times that imaginary 1 gets us 2 irons. So then we look. We have 2 irons on each side, 3 oxygens on each side, 6 hydrogens on each side. We are balanced. Ooh, but I can't spell. So there you go. That is how you balance things. So I would always go through this process. Once you get really good at balancing, you're not going to need these atom counts down here. And that's okay. You actually don't need to show these. I know that I'm always big on, show your work. But a lot of this, once you get good at it, can be done in your head. And it doesn't require you to show work. So for balancing chemical equations, you do not have to show your work other than for this balancing lab, which I'll explain in another video. But for moving forward with balancing chemical equations, you won't have to show your work. You just need to make sure the numbers in the front, right, those coefficients are correct. So here's another example. So we have phosphorus and oxygen, and phosphorus and oxygen. If you're feeling confident, you can pause, try and balance this, and then come back for the solution. If you're, still lost, keep playing the video and I will keep walking through it. So on the left, we have 4 phosphorus, and then we have 2 oxygen. And on the right, we have 2 phosphorus, and we have 5 oxygens. So we're not balanced even a little bit. Nothing's balanced. So we need to start putting numbers in the front so that they will equal each other. So if we're looking at these phosphorus, all right, we have 4 phosphorus on the left, 2 phosphorus on the right. So we need to put something here to multiply by this 2 that's already there to get us 4. So we're going to put a 2 here. 2 times 2 gets us 4. So then that will be 4. And so when we do that though, right, this distributes to the phosphorus, but also distributes to the oxygen. So that changed our number of oxygens on this side. So now we have 2 times 5 gives us 10. And so now looking at the oxygen, we need to put a number out front here that will multiply by the 2 to get us our number of oxygens, right, to get us 10. So we'll put a 5 out front. So 5 times 2 gets us 10. Then we double check, 4 phosphorus on each side, 10 oxygen on each side. We are balanced. So this type of reaction is a little more challenging. This is called a combustion reaction. And combustion reactions are notoriously hard to balance. This is the one that I showed balanced before, but I'm going to go through the process of showing you how to do that. So we're going to talk about reaction types next time, but like I said, this is combustion, and so that will make more sense after the next set of slides. But combustion reactions are tricky. So I would always do carbon first, right? Do carbon, and then I would do hydrogen, and then I would do oxygen, and always do them in that order. Don't ever change the order for a combustion reaction. Do carbon, then hydrogen, then oxygen. So looking at this, we have carbon, hydrogen, oxygen. Carbon, hydrogen, oxygen. And the reason we balance oxygen last is you'll see it shows up in 2 places on this product side, right? It shows up here and it shows up here. And since it shows up in so many places, it can really throw you off. So always do oxygen last. So let's go through and do our atom counts. On the reactant side, we have 1 carbon, we have 4 hydrogen, and we have 2 oxygens. On the product side, we have 1 carbon, we have 2 hydrogens coming from the water, and then we have 3 oxygens total. We have 2 from the carbon dioxide and 1 from the water, which gives us 3. So in looking at this, our carbons appear to be balanced at the moment. Our hydrogens are not, and our oxygens are not. So like I said, I would go through, our carbons are fine, so we're going to do our hydrogens next. So we need to put some number out front here to multiply by that 2 to get us 4 like we have on the other side. So we'll put a 2 there, which will change this to 4, and then we can do, right? And so when we do that, that also is changing our number of oxygens on this side though, because that 2 gets multiplied. So now we have 4 hydrogens, yes, but we also have 2 oxygens. So total on this side, we have the 2 coming from carbon dioxide plus now 2 coming from the water, which gets us 4 total on this side. So we have 4 oxygens. So now looking at this, we need to put something out front on the reactant side to multiply by that existing 2 to get us 4 like we have on the other side. So we'll put a 2 here. So 2 times 2 gets us 4. And now it's balanced. 1 carbon on each side, 4 hydrogens, and 4 oxygens. So like I said, this particular type of reaction is a combustion reaction, and they can be a real pain, but always do it in this order: carbon, hydrogen, oxygen. My tip for combustion reactions is if you get stuck, and you'll see you may get stuck. If you get stuck, double the hydrocarbon. Double the hydrocarbon. And by hydrocarbon, I mean something that has both hydrogen and carbon. It may also sometimes have oxygen, but it always has carbon and hydrogen. And that's usually going to be this guy out in the front. So if you get stuck, put a 2 in front of whatever the hydrocarbon is, and then try and balance it. But But when you put a 2 out front, erase everything else that you've done. Like go back, start over, put a 2 in front of the hydrocarbon. And usually that will fix a lot of your problems with combustion reactions. So sometimes you'll get into a point where you need to simplify an equation. So here's a problem. Is this one balanced? So if we look at this, we have hydrogen and oxygen on each side, right? So I'm just going to put them up here. So on the left, right, we have 2 times 2, which gets us 4 hydrogens. And we have, 2 oxygens on that side. And on the other side, we have 2 times 2, which gets us 4 oxygens. And then we have 2 times an imaginary 1, which gets us 2 oxygens. So, yep, it's balanced. But what about this one? So we still have hydrogen reacting with oxygen to produce water. So if you went through and did the same atom count, you would realize that you have now 8 hydrogens, 4 oxygens, 8 hydrogens, 4 oxygens. So it's still balanced. So which one's right? Well, technically they're both right, but whenever you get into this kind of situation, I want you to simplify it. So the way that you can simplify it is, if you notice, like in this second reaction, all of these, 4, 2, and 2, they can be divided by 2, which means that this can be simplified. These can all be reduced. So you go through and you divide all of those coefficients by 2 to simplify it. And when you do that, you'll actually get this reaction. So when you're balancing, always make sure that your reaction has been simplified. So now your job, go ahead and work through problems 6 and 7 on the lecture worksheet. There's quite a few reactions there. For problem 6, don't do the types of reactions yet. We'll do that next time, okay?